last piece we need to do in this 2-unit section of probability is what we call conditional probability. So when we already know something about the problem. So conditional probability, event A, given that B has already happened. This is one formula we can use. Probability A, and then we have a slash B. So that means A, given that B has already happened, or we already know about B, is the probability of A and B, so but divided by the probability of B. The other way you could do it is just count the number of elements in the sample space, things like that. So number of elements in A intersection B divided by the number of elements in the set B. If you want to work out whether A and B are independent, we can use conditional probability for that. If the probability of A, given that B has already happened, is exactly the same as the probability of A, then they must be independent events. Because the fact that B had already happened didn't affect the probability of A. So they're independent. Another way of looking at that is you could say probability of A intersection B is the same as probability of A times probability of B. Right, so we've got a mixed language class. Students are studying French, Latin and Japanese. Oh, sounds like our Year 7th. The number of students who study each language, we have our Venn diagram there for that. Okay, so probability of French, given that they do study Japanese, well, we can have a look at it with a Venn diagram. Yes, we've got these formulas, but we could really just look at the set of Japanese, because given that they study Japanese, how many are then in the French? Well, 3. So 3 out of the 10 that are in the Japanese. So with a Venn diagram, we don't really need the formulas. We just look at the diagram and do it. 2 boxes each contain 4 stones. The only thing that differs is the colour of the stone. So box 1's got 4 black stones. Box 2, 2 black stones, 2 white stones. We're going to first of all choose a box at random and then draw 1 stone from that box. So the first question here is the probability that I pull out a black stone. First we've got to pick a box. So probability of black would be, well, there's 2 different things that could happen here. I could choose box 1. Now if I choose box 1, the probability of picking out a black stone would be 1. So there's the half. Or, so we add the probabilities, I could choose box 2, and there's a half chance of doing that, but in this case there would be a 2 in 4 chance of pulling out a black stone. So all up, that's 3/4 chance. Of course, the other way I could have done it is say, well, really it doesn't matter which box I pull out. I could just say, well, look, all up there's 8 stones. I'm going to pull 1 of them, and I'll get 6 of them are black. So I've got 6 in 8, 3/4. Yeah, 2 different ways you could think about that problem. Now, this time, so we don't know which box the stones come from, but we do know the box is black. So someone's pulled it out and then it just showed it to us. Look, I've got a black stone. So what's the probability that they pulled it out of box 1? So now what we're saying is the probability of box 1, but we know the stone is black. So that's the condition. We know it's black. So probability of black and box 1 divided by probability of black. Well, probability of black and box 1, that was a half. Probability of black, we just worked out, was 3/4. So we get a 2/3 chance for that one happening. 2/3. Let's do another one. In a school, 55% male, 45% female. Now, of the male students, 13% say Monday is their favourite day, while 18% of the females say Monday is their favourite. So what's the probability that a student chose at random is male whose favourite day is Monday? Well, we know the probability of male is 0.55. Probability of Monday, given that it's a male, so we know it's a male, probability it's Monday, is 13%, so 0.13. So probability, given that we've chosen a male, that it's Monday, is equal to probability of Monday and male, divided by probability of male. So I can still use that same formula, but just rearrange it to work out our problem that it's a male whose favourite day is Monday. So subbing in the information, rearranging it, and there we go. We've got a 0.0715 chance of that particular one happening. All right, so 12G, we'll finish off our look at 2-net probability.